Very good morning to all my dear friends, my dear students, and the viewers. I am Professor Ashwati Fuljele, Assistant Professor in the Department of Mechanical Engineering. Welcomes you all for the today's online lecture of Advanced Manufacturing Techniques, an elective subject of 8th semester Mechanical Engineering. My dear friends, in the series of non-conventional machining process advanced machining technologies, we have seen the overview about non-conventional machining processes in our previous video, wherein we have briefly discussed what types of non-conventional machining processes are there, how those machining processes differ from conventional machining processes, and what was the need and what was the requirement behind generating those non-conventional machining processes. We have quickly overlooked into the non-conventional machining processes. Today, as you can see on your screen, we are focusing on the water jet machining and other associated processes. My dear friends, as the title itself depicts, that a jet of water, a stream of water, is utilized to perform the machining process. Wondering that how could a stream or jet of water can perform a machining process, and that too cut or drill over the surface of a metal, right? So this is the advancement and the miracle of modern technology. We have utilized the jet of water to perform machining process. Here in this today's video, we are going to talk about its introduction, the working principle, the machining system, wherein we will be discussing about its construction, the instruments those are associated in this process parameters, of course, applications, advantages and disadvantages. We all are aware that these processes are advantageous, but we will give specific time over the disadvantages. Right. Now, talking about the water jet machining process, as we are assuming, as we are imagining about this process like a stream or jet of water, and of course that stream or jet of water must possess huge kinetic energy, that it should be flown over the surface of the workpiece with very high velocity, and that ranges from 900 meter per second. That tremendous velocity will certainly affect the workpiece standing in front of it, and the mechanical erosion will take place. The key element in water jet machining is a jet of water which travels at velocities as high as 900 meter per second. When the stream strikes a workpiece surface, the erosive force of water removes the material rapidly. The water in this case acts like a saw and cuts a narrow groove in the workpiece material. It is thin stream or thin jet is created, it is emerging out of the nozzle. We are going to see the constructional parameters of this process, and that high energy, high kinetic velocity pressurized stream jet will perform the cutting and drilling operation, right? Apart from that, we are not only cutting the metals but also concrete, ceramics, wood, rubber, plastic can also be cut with the help of this machining system. The water jet machining involves directing a high pressure ranging from 150 to 1000 megapascal, high velocity ranging from 540 to 1400 meter per second water jet to the surface to be machined, and that to the diameter of strain, that jet is restricted to less than a single millimeter, isn't it? It ranges from zero point 0.2 to zero point 0.8, isn't it? The bulk of kinetic energy of jet is converted into pressure energy. If the local pressure caused by the water jet exceeds the strength of surface being machined, the material from the surface gets eroded and the cavity is thus formed. As we have discussed earlier, that mechanical erosion is taking place over the surface of the workpiece. Now, let us talk about the main constituents of this machining system. What is water jet machining comprises of? It consists of mainly hydraulic pump, intensifier, accumulator, high pressure tubing, jet cutting nozzle, and the catcher. We are going to discuss each one of them in much detail, but all those components will play, each one of them will play a vital role in water jet machine. Of course, to energize the water, we must use the pump unit, hydraulic pump unit. The intensifier and accumulator will intensify the stream or jet of water. An accumulator will eliminate the pulsation. The high pressure tubing are somewhat different than the normal piping system, as the water flowing through those pipes are at high pressure, possessing high kinetic energy. Those we must be conscious while selecting those piping units. Jet cutting nozzle, of course, a stream jet has to be emerged out of the nozzle, and in the end, a catcher. The catcher is nothing but a reservoir wherein the water will be collected in the end of this process, and again it will be recirculated with the help of pump and the filter system. Let us look into the construction feature. A general construction of water jet machining can be seen on your screen. A fluid supply, in the left hand side you can see it clearly, wherein a mixer and filter is there, right? That filter is usually required to eliminate any, for the filtration, to eliminate any of the contamination. The water should be clean, right? There should not be any of the foreign particle apart from water. From that fluid supply, the pump set is receiving water and flowing to the accumulator, and one set of intensifier can be clearly seen. With the help of this pump set and intensifier, we are rising the kinetic energy of this water. The role of accumulator here is to eliminate the pulsation, as we all are aware that the water coming out of any tap, a regular tap, is pulsating. The frequency is uh, fluctuating. It should not be happening like in this process. And other part is like to maintain its kinetic energy and the pressure. Several control valves along with the hydraulic unit can be seen here, and before going towards the jet, another valve sets are there, and in the end, in the right hand side you can observe a jet of water which is striking over the surface of the workpiece and thus machining operation can be performed, and in the end you can see drain at the bottom. That is the water collecting reservoir. This water is further uh, reutilized, recycled with the help of filtration and other processes, and thus it is again supplied to the fluid supply, fluid reservoir. Right. Now the role and responsibility of each one of the component in this hydraulic system in water jet machining. The pump, hydraulic pump, it is powered from 30 kilowatt electric motor. It supplies oil water at pressure as high as 117 bar. Compressed oil, my dear friends, don't get confused about the uh, presence of oil here. We mostly use water as it is more cheap and more economical for specific purposes. As we all are aware that water gets reacted with some of the materials, for that case we are using oil here. The compressed oil drives a plunger system pump termed as intensifier. The hydraulic pump offers complete flexibility for water jet cutting and cleaning application. Cleaning application, I'll give you one reference, like in any of the servicing center of the automobiles. Firstly, the water is cleaned out, right, from the surface, or even though at the bottom section the water is a high stream, high jet of high energy jet of water is used to clean the automobiles, right. The it is also supports single or multiple cutting sections stations for increased machining productivity. The detailed block diagram for this setup, wherein we can see through the different components of accumulator, intensifier, hydraulic pump set, the role of electric motor, the hydraulic pump, and their directions. The piping systems utilized here are having certain special mechanical property to sustain the high pressure. Intensifier, as we can guess from the title, it is usually used to raise the intensity. It is used to raise the pressure of water flowing through the pipes, right. With in the absence of intensifier, we would not be able to energize the water to we would not be in position to increase the kinetic energy of water flowing through the pipings. Thus we are using intensifiers here. Accepts the water at low pressure and it expels through an accumulator at higher pressure from 3800 bar. As you can observe here, what kind of multiple amplification in the energy, in the pressure from 4 to 3800 bar, right. The intensifier converts the energy from low pressure hydraulic fluid into ultra high pressure water. The hydraulic system provides fluid power to piston in the intensifier center section. As one side of the intensifier is in the inlet stroke, the opposite side is generating ultra high pressure output, right. This is what the role and responsibility of the intensifier in this setup, isn't it? During the plunger inlet stroke, filtered water enters the high pressure cylinder through the check valve assembly. After the plunger reverses direction, the water is compressed and exits at ultra high pressure. The accumulator discussed earlier, in short, the accumulator will eliminate the pulsation of water flow, right? The accumulator maintains the continuous flow of the water at the high pressure and eliminates pressure fluctuations. It relies on the compressibility of water in order to maintain a uniform discharge pressure and water jet velocity. When the intensifier piston changes its direction. One another point I would like to mention here, like as we have studied in our previous semester, like in the flow through pipe, there are two main losses in the flow through pipes, right? First one is the major loss and another one is the minor losses. The major loss is nothing but the friction between the water molecules flowing inside the pipes. What about the minor losses? Minor losses are like sudden expansion, sudden contraction, bending, and many more. But if we could talk about major losses, the friction between the water molecules is a major loss, right? That may result into the cavitation, and in order to eliminate this, we have those accumulator and the intensifier here. And of course, the high pressure tubing system will play the eliminating the cavitation, isn't it? Even though friction between the interior, periphery, internal surface of the tube and the water molecules are also a type of minor losses. Today we will stop here, and in next video we will discuss from the same point towards the next topic. Thank you for your patience in listening and your valuable time. Thank you.